Hello, this is Trevor. I'm working on the CSAW 2022 CTF challenges, and I'm going to start in the crypto. I'm on a team, and looks like somebody solved a couple of the other ones, but we're going to start in the crypto realm. With this first one, gotta crack them all. Let's pull it up. If the site will... Seems like the site's having a few issues. I haven't solved any so far, but just getting things to work seems to be a challenge. All right, well, there we go. And of course it disappeared. Okay, sorry. So gotta crack them all, 124. This is the points I think I get. As an intern, blah, blah, blah. Security issue. There's a word list. Stream ciphers. We get a list of encrypted passwords, including the admins. We get the encryption algorithm and your password, which is the plain text. And we need to crack them all and get the admin's password. And we can connect to a box that will encrypt a password for us. We have 3 files: encrypt, leaked passwords, and encrypted passwords. And the flag is just the admin's password. Sweet. All right. So I've downloaded already the 3 files and I'm ready to go. Let's start with the encrypt. Whoops. Vim encrypt.py. Take a look at that file. So we've got, I'm going to fix the errors. It's saying that it doesn't like the tab. So I'm going to, in Vim, I'm going to read tab and hit enter. I will change those from tabs to spaces. It doesn't like that there's no white space there. Doesn't like that there's not 2 lines. And then again, white space after this column. These don't matter. But I don't want Vim to complain at me. So I'm going to just fix those. And then it says line too long, whatever. Okay, so right here, we're opening a file called t.text, a read-only in binary. And we're reading that key. And then we've got and defining the variable key. We've got a function encrypt that accepts an argument named plain. And what we're going to return is a binary. It's going to join a list. Here's the definition of the list from there to there. So what we've got, let's start at this end. We've got zip, plain, and key. We already know what key is. Plain will be that argument. Zip will take 2 iterators and return the first value of each of those iterator, then the second and the third, and it's in a generator. So I don't know how to, I'm not good at defining what a generator is, but I can show you. If I do A equals foo and B equals bar, these are strings, but in Python, they're iterable also. So I can do zip A comma B, save that as C, and then I can iterate through this generator for X in C, print X. And you can see it returns a tuple of the first character, then the second character, then the third character of each of those inputs. So that's what zip does for X and Y. So we're going to save, like in this case, F as X and Y as, or B as Y. And then here, and that's going to be passed to this part, we're just taking the ordinal of the first value of the X, and this is XOR, so we're XORing that with Y, converting it to bytes using big endian. Sweet. So with that understanding, we should be able to solve this as long as we have, so we know what the encrypted output looks like, and that'll be these values. And we have this unencrypted plain text, which hopefully is in one of the values in here, so we can verify that our solution works. And the key to this is XOR is reversible. So if I do, let's do ORed of A, just to know what it is. It's 97. So if I do 102 XOR with 97, I'm going to get a number, which is 7. Now I said it's reversible, so that means we can do 7 XOR with 97, and we'll get 102. And 7 XOR with 102, and hopefully you know we're going to get 97. Cool. So with that in mind, let's start solving this. We're going to use the goal to solving it, or the steps anyway. So we're going to take this plain text and we are going to encrypt it. How are we going to do this? We're going to, oh, we don't have the key. So we can what we can do is take this plain text, use that service to encrypt it so we know what the encrypted text of this is, and then XOR those together, which should give us the plain text. Let me write down our steps here. Kate 1, encrypt plain text using service. That'll give us the encrypted text. 2, XOR encrypted text with plain text. This will give us, this will equal the encrypted text, and this will equal the key, right? Because I said it's reversible. So we XOR the plain text with the key, that gets us the encrypted text. If we encrypt or take that encrypted text, XOR it with the plain text, we get that unknown value, which is the key. Using the key, we are going to decrypt all of the passwords that are found in this list. Once we have those, we should be able to identify the admin password, I hope. But that's the steps we're going to do. So let's start with encrypting plain text using service. So I'm going to go here and go there, copy this here, paste. And we can only encrypt pre-approved. We know this one is pre-approved. So I'm going to paste that. And we get this back. So I'll just copy this all. Copy, and I'm going to save this. Key equals this. And no, I don't want to do that again. So I'm going to exit this window because I don't need it anymore. What the heck is going on here? There we go. Okay. I need our, so we've got, oh, sorry. I saved that as key. I didn't want it to be saved as key. I wanted it to be saved as encrypted text or password. We don't know the key yet. We know the plain text, plain text equals, okay. So we have the plain text and the encrypted password. Now we need to XOR the encrypted with the plain text. So we can do it exactly like they did it here, right? So we can do key, right? Because this will give us the key, equals b.join ord x XOR with y. I'm just basically copying everything so far. Big for x comma y in zip. This is where I want to change things. So number one, I want plain text to be the first input, and I want the encrypted password to be the second argument to that zip. And then close the join. That looks good. Hit enter. We should have the key now. Woohoo. All right. With the key, we should be able to decrypt this encrypted password and get the, let's do that to make sure that we've got it right. So we want b.join ord. We can define this in a freaking, let's do, yeah. We'll do the same, but we're going to add a key parameter. Def encrypt plain key return b join. I'm just going to copy from here to the end. So instead of typing this out every time, we now have a function, right? Now, if I encrypt instead of, I said I wanted to XOR, I've got the key, so I want to test our key by entering in the plain text, and I want to give it the key. What I expect to have this equal is the encrypted text. Looks pretty good. Let's do it equals encrypted password. And that's this one right here. Boom. Exactly the same. So we have the key now. With the key, we can decode all of these. Let's do that. So I want to do with open encrypted passwords .txt. I want to open it in read-only binary as f. So I want all passwords, all encrypted passwords. Remember, these will still be encrypted. Equals f.read.split lines. This will read all of it, split it by lines, and that way we could also do like read lines, but that will have a, carriage return at the end. These won't. And just to show you, I can do all enc passwords. Boom. There we go. We've got a list with an entry for each, and then we can do for enc passwords in all enc passwords. That's what I named it, right? Yep. We can loop through those and then do encrypt the plain text. So we want the key. We want enc password, which is the encrypted value. We're going to XOR that with the key, which should give us the plain text. Print, or we can do plain, we can save this, plain text. Let's do this. Plain text passwords equals a list, and then we'll do plain text passwords dot append this. Run through that. Oh crap, we messed up. What did I enc password, which should be this for enc passwords. All right, I messed up. I don't know how I messed up. Oh, it's because of the ORD. This is already in binary. So we want, sorry. I'm going to change, I'm going to go to our definition of encrypt, and I'm going to create a new one called decrypt, plain, and I'm not going to, there. That's the only change, is to make it so that I don't take the ordinal value. What's the issue here? Oh, join, crap. I need another, there. Okay. Now with decrypt, I want to use that instead of encrypt here. And I probably made this too complicated, but let's take a look at plain text passwords. Boom, there we go. We got a list of all of them, and they're all in binary. So we can do for X in plain text passwords print x.decode. And there we go. We have all the passwords, and you know, the administrator is probably going to be this one. If I was good at leet speak, looks like insecure something. I don't know what it is. Anyway, yeah, so that's it. So let's submit this and check to see if we got it right. I don't know what this says. Insecure 5 ST maybe? I don't know what the 2 is. Oh, stream. STREAMCIPHE. I wonder if it needs an R. I mean, we don't have one, so. I submitted it, didn't I? Site. It's having issues. Anyway, so that's it. All we did was we took the plain text and the ciphertext right here. We used the service provided to get the encrypted text, and then XORed these two together to get the key, because XOR is reversible. With the key, we then used that to XOR all of the encrypted ones, which ended up with the plain text, again, because XOR is reversible. Once we had all the plain text, we found one that looks like the admin, one that doesn't fit, And this has got to be the admin one, which, if this would just let me submit it, we could solve this freaking challenge. Anyway, I'm not going to belabor the video just because something's not working here. I'm 90% positive that I've got it right. The only question is whether I need that the 2 at the end. Insecure. Yeah, the 2 would be an R to make it a complete word. All right. Well, if you have any questions, definitely let me know. This is a fun challenge. I like these. So, cryptography is very hard for me. I'm still learning and trying to get better. So that's why I do it. It's because it's, the challenging ones. All right. Talk to you in the next one. Thanks so much. Goodbye.